Hello, ladies and gentlemen. I'm here with you again. Today we will have the second part of our 10th lecture, or if you prefer, this is an independent, lightweight lecture. We will be talking about just one design pattern. As usual, I would like to provide you with a common picture related to the variety of design patterns as before. I have made the initial slide a little bit more compact, not to extend the number of slides. Nevertheless, our idea, just to remind you, our idea is to consider design patterns, discussing examples of using that. Of course, each pattern, actually, let's look at the second point in this notice. Each pattern reflects a real problem you face when you design a software system, a piece of software. So it reflects a problem and provides you with the solution to that problem. So we will keep this approach throughout all our course, and we will do that exactly the same today. So this is the overall taxonomy. I usually put this slide in front of each lecture, and just a kind of common remark. Now we will concentrate with behavioral part of this taxonomy. That is patterns that are concerned with the assignment of responsibilities between objects. They concentrate in behavioral aspects of functionality of objects, including mutual functionality of objects. And as you see on the slide, today we will discuss just one pattern, which is called chain of responsibility. Okay, what's the point? Here is, excuse me, let me move my picture a little bit aside. The chain of responsibility. Erich Gamma gives the following definition of this pattern. Avoid coupling the sender of a request to its receiver by giving more than one object a chance to handle the result. So it decouples two parts of your software system, or two parts of functionality of your system. There is a request or a call for some services, and this pattern just decouples sender of the request or caller from the callee from the caller, and chain the receiving objects and pass the request along the chain until an object handles it. This is a kind of second point. Please look at my remarks on that. So decoupling sender and receiver means that to make sender and receiver independent from each other in some sense. We will see that on the examples. And the second point says that the solution is to pass the request along several receivers until finding the receiver responsible for handling the request. I understand that these are just common words. It is not clear how this definition actually works. But again, we will see that on the examples. And final remark here is that for those of you who understand Russian, I would provide the following Russian translation to that name. Chain of responsibility means цепочка ответственности. Okay, this is just my proposal. Well, you can probably see various translations of that of the name of that pattern. Okay, let's go on and start considering examples. Look at this slide. Consider a software system that is represented as a hierarchy of classes. Yes, this is a completely typical thing when we have ever a set of classes that are organized in some hierarchy using inheritance as usual. Just two examples of such system: multi-window text editor and automatic answering system, or simply speaking, a call center, automatic call center, or even call center working without software support, just a lot of people with telephones answering questions. It doesn't matter. There are similar order or similar way of functionality of such a system. Okay, and what can we say about such systems? Well, imagine a multi-window text editor. What do we see there? A lot of windows that present simultaneously all together on the screen. For example, we need to get some help from this text editor. The obvious question is, which component of that text editor is responsible to provide help with you? You obviously know that there are different kinds of help information in such system. There is definitely a help subsystem in software like this, and there are different kinds of help, different kinds of information describing various aspects of functionality of a text editor. So the question is, who is responsible for giving you a help for some particular aspect? The same idea or the same question or same problem is about answering system. The problem is which operator, and automatic answering system assumes a set of operators doing communication with our outer world. So which operator is responsible to answer on a particular question? As you might see, the idea behind these different systems is conceptually the same. Okay, look at this composition. Software, like examples above, text editor, answering system, etc., many others, are organized like as shown on the picture. Such software can be represented schematically as a hierarchy of classes, I would say. Look carefully at this picture. Does it seem familiar to you? If you remember one of our previous lectures, we will definitely see this picture for the topic called composite pattern. When we discussed composite pattern, we used just this picture. So this is why I have shown you this picture on this lecture. The idea is that the chain of responsibility pattern is often used together with composite, and I'm going to show you the similarity. So, okay, let's take the first example, an answering system. Look at this configuration. An answering system, I don't care about whether this system is automatic or not. Conceptually, they are organized in a very similar way, whether operators are people or software components. It doesn't matter, actually. So look, there is a hierarchy of operators. Again, operators can be people or software components. It doesn't matter. The task these components solve is answering questions or provide reactions on a request, on requests. So, this hierarchy reflects the level of responsibility of those operators. Again, each operator performs the same functionality. It accepts requests and provides the answer. Or if we are talking about software component, it gets called and should provide the result of that call. And this hierarchy reflects, as I have said, the level of responsibility. Simply speaking, the lower level of this hierarchy has the lowest responsibility. Simply speaking, this means that these operators know a kind of small part of information. They are responsible to give simple answers on particular, relatively simple questions. The next level has higher responsibility. They can give answers on more complicated questions or requests. And there can be a lot of levels of responsibility, and the higher level is well, a kind of God. He or she or it knows everything. It is able to, he, she, or it is able to give the answer to any question. Of course, this is a kind of idealistic scheme, but the idea is quite actual. So what's happening? What's happening when a request comes from the outer world? So look at what I have drawn here. Suppose a request comes to an operator, and the contents of this request is quite simple, so that the lowest operator can give an immediate answer. In that case, the act of communication just terminates on this level. Request comes, operator gives the response. That's it. What happens when the request is so that the lowest level operator cannot give an answer? It just doesn't know the answer. In that case, look, the lowest level transfers the request to the upper level, so that the upper level operator decides whether to give a response or not. Or suppose, for this case, the higher level operator is able to give the response. For that case, the act of communication terminates successfully. Operator gives the response. Okay, and the other case, the more hard case, is that a request, an input request is quite hard. In that case, the lowest level operator transfers it to upper level. Upper level operator decides that, or concludes that, only the highest responsibility level can give the response. For that case, mid-level operator again transfers this request to the upper level. Of course, you can ask if the highest responsibility level still cannot give the answer, but I don't know what happens. Probably the request is left unanswered. But it doesn't, I'm not interested in that, just because I'm interested in the idea of functionality of this pattern. The idea of this pattern is that the request gets passed across a structure until it finds the component that is able to give the answer or give the response. Okay, this is a conceptual scheme. Now we will consider a more realistic software, completely software example. We will take multi-window text editor as the example. Look, excuse me for probably not very good picture. This is a schematic picture. I tried to draw a multi-window text editor. What do I have on this picture? I have a variety of windows, several windows, containing different kinds of information. Program text, a kind of scheme, a kind of regular informal text, and a menu on the upper side of this configuration. And I assume that there is one window is so-called active. This is on the very top among the other windows. Absolutely typical situation, absolutely typical, but still a little bit schematic situation. It is quite enough for me to have such a configuration to discuss the functionality of a chain of responsibility pattern. Okay, so, and let's consider the problem with the help. As I have said, each system like this has some help subsystem. Simply speaking, we would like to get additional information or explanations about what does a part of this system mean. What can we do with the active window, or what can we do with menu items, etc., etc. Very typical for that situation is that a user can press a button devoted for getting help. For example, F1, functional key F1 to get a help. Also, there can be a combination of keys like Control F1 to get some other kind of help. Here is the assumption. Suppose we have the following key and combinations of key. If a user presses F1, he or she gets the common help about the whole the functionality of the entire text editor. At the same time, if he or she presses Ctrl F1, he or she gets so-called context help. That is the help which is related to the particular part of the editor. For example, if the program window on my picture is active, so by pressing Ctrl F1, the user gets information or explanation about how this active window works, or what can he or she do with that window. This is a typical situation. Probably I wouldn't waste a lot of words explaining this idea. My wish is to discuss how this functionality is supported by the text editor software. Okay, this is just the comments of what I have already said. Main help is to be displayed for F1, and specific or context help will be provided by pressing Ctrl F1 combination. Okay, look at the next slide. Here I have shown the approximate dynamic configuration of this text editor. This is software that keeps such or similar information about this text editor. What is the idea? As you might see on the previous slide, there are several components that support corresponding elements of this text editor. What do we have? We have a menu with menu item. We have windows containing different kind of information, program window in this particular point of functionality. We have three windows open: program window, scheme windows, let it be scheme window, and text window. Okay, and program window is the active one. Please notice that this is not a component hierarchy. This is just a dynamic structure of the editor's current state. We will see the static structure a little bit later, just to make the difference between static and dynamic structure. Anyway, we have the component editor, which contains information, all information about the editor as a whole. We have a set of menus composing the main menu of the editor, and we have a set of windows that are open at this current moment. Okay, so suppose there is the request came to active window, because this window is active, and if a user pushes Ctrl F1, sorry, excuse me, if the user presses Ctrl F1 combination, then this request comes to the program window. And program window, this is a part of software, just the instance of a class, obviously, should handle somehow this request, because the semantics of this request assumes that the user wants to get the information about this program window as it is. So therefore, this component is able to handle this request immediately, because the request is about just this active window. Okay, no problem. Program window component receives the request and processes it. What does it mean? Here it processes it. It just displays a window with a help. Probably that's it. Or probably it outputs a kind of explanation line on the bottom bar, or anything like that. I don't care. Okay, what happens if the active window receives F1 request? This is not about this particular window, but the request is about the whole system. Pressing F1, the user needs to get a common information about the text editor. In that case, program window decides that this request, it is not responsible for this request. Therefore, this window transfers the control to the upper window, to the window it belongs to. On my slide, the window that is the owner of program schema text windows is a kind of specific component that holds all the set of windows. I called it windows in this picture. If we remember the composite pattern, then we will have a special name for such composite windows. Anyway, the request gets passed to this window. The Windows component getting this request, it understands that this request is not for it. It is not responsible for that request. Therefore, it transfers the request to the upper component, editor on my picture, which is responsible for giving the response. And the editor provides user with the explanation, displaying a window with the help information, or outputting some information on the status bar, or in some other way. So this is the idea. Again, the idea of how chain of responsibility pattern works. And my pre-last slide is about the program implementation of that pattern. Probably you are experienced enough in programming in object-oriented style. I guess you already understand of how to implement such a functionality, such a behavior. Look at the code. To completely understand this code, you need to go to composite pattern, because I have reused some things from the implementation of the composite pattern. Anyway, there we had two kinds of components: leaves and composite, probably composite classes that are derived from component class. Component, and it is on my picture right now, is just the root class for all kinds of other components, or compound or terminal or leaf. Okay, anyway, look at what is written here. We have some common interface in this component class. This interface is the same as for composite pattern. I don't care about them. I'm just interested in the things I have added to that root class to implement chain of responsibility. There are two things. Look, the member called owner and a method display help. Oh, excuse me, I have a bug here, not help, but help, excuse me. Probably understand what did I mean. Okay, so because all other elements of our software are classes derived from this component class, they inherit these parts, owner and display help. Well, owner, being a member of that root class, doesn't need to be redefined. It's just inherited by other classes, whereas display help method should be, being abstract, should be overridden in every derived class. So look at what is written in the rest of implementation. Don't be afraid about a great number of elements on this implementation. It just I hope they won't puzzle you. So anyway, again, to completely understand this implementation, I would ask you to refer to the composite pattern, because this piece of code was just reused from that. As I have said, these two patterns often live together with each other, a composite and chain of responsibility. So look, what do I have here? I have a class called editor, okay? It is the derived class, the class derived from component. Therefore, it inherits owner, and it should override display help method, abstract display help method from the root class. Get, add, and remove elements are the same as in the composite pattern. I'm not interested in that, but of course, we still need them to support the typical functionality of editor components. Okay, so what do I have next? We have Windows class. It is also derived from component. Actually, in reality, it could be derived from composite, because this class contains a set of elements. This is a compound class. Look at the Open Windows member. This class, Windows, has a set or list of windows that are open for the moment. This is a dynamic element of the class. And look at the key point of our implementation. So all windows from the list refer to the main. This is an important point. Look again at the root class component. It has a owner element. What I didn't say anything about the semantics of this member. Owner class refers to the component that it belongs to. Coming back to the previous slide, look, the key idea of implementation of this configuration is that each component has the link to the component it belongs to, and the request gets passed just using that link. So in the implementation, this link is represented by the owner element. So coming back to this point, here all windows that are open for the moment has the owner that refer to the instance of the Windows class. So this is the support for transferring requests along the configuration. And look at the key point of the implementation, this method, display help. So this is the overridden version of display help for Windows. What does it do? Look carefully at what does it do. When it gets the request, Control F1, then it decides that this request is for just this window, okay? And it decides that I am able to display, handle this request myself. So it decides to do some actions, displaying help window or outputting the information on the status bar or anything like that. If this class or instance of that class doesn't gets some other request different from Control F1, simple F1 in our example, then it decides that this request is not for me, and it just passes the control to the owner. Simply speaking, it calls display help from the owner, from the component which is the owner of that class. So this is the key point. So this this element, I don't know whether my cursor is visible on your side. So anyway, owner.display help call is just the implementation of transferring the responsibility to the other component. Well, the same idea should be implemented throughout all window or all components in the software system, including menu. In our example, I don't have enough room to write the same functionality for menu. This looks exactly the same as display help overriding display help on Windows class. Okay, so that's basically it about implementation of chain of responsibility. My last slide is to emphasize the difference between static and dynamic structure of such a system. Look, when we writing the code implementing such a software system and implementing chain of responsibility pattern in particular, we have the static structure of such a system. The static structure is composed of classes, and the relationships between classes is called, obviously, inheritance. Sometimes we use delegation, as you know, and I would definitely prefer delegation, but inheritance still very powerful means for building such structure. Anyway, this is class hierarchy. These are components that relate to each other using inheritance. For example, any software component of a text editor is editor class, menu class, window class. Window class, in turn, has a derived class that reflect different kinds of windows, for example, text window, scheme window, program window, etc. Okay, so this is the static structure. We know that very well. We use it often each time we are programming something in object-oriented style. And my very important point here is for you is to make the difference between this static structure as we see in the program text and between this and dynamic structure of the software system. Dynamic structure means that we have created some instances of these classes, and these instances are in some relationships with each other. Look, here is just the same configuration as on one of the slides before. It shows the dynamic configuration. Here we deal with not with classes as on the left side, but with instances of those classes. And these instances are in some relationships with each other. Look, blue arrows reflects the ownership. For example, editor, the root instance of the software system when it is running, owns menu and Windows instances. Those instances in turn own menu items and Windows instances respectively. And look at the red lines. Red lines reflect ownership. Each menu item belongs to menu. Each window belongs to editor. Each window belongs to Windows collection or list of windows. Each Windows collection belongs to editor. So this is the dynamic configuration. And when we are talking about chain of responsibility pattern, we deal with dynamic configuration. We are discussing the relationships which are dynamically set up while program is running. So on the right side picture, we have instances of object that dynamically connect or relate to each other. By the way, when we open a new window, such a window is added to the Windows collection. Menu also can dynamically change its configuration. For example, in many real systems, it happens very often. For some case, we have one set of menu items. For another state, this set of menu item changes. So anyway, we have dynamic structure, and we were discussing dynamic structure. And the chain of responsibility, key point of the implementation of the chain of responsibility pattern is the ownerships, aspects of ownerships. Owner, member of all instances reflect the ownership, and the requests get transferred using that, I would say, backward references. So basically that's it for today. I hope everything more or less clear for you. That's it. Next time, I hope within this week, I will provide you with the next, I hope, full-sized lecture discussing other behavioral patterns. Thank you for your attention. See you again, or hear from you again soon. Thank you.